Hello guys. So Demaya Hughes told me that the Faraday simulator on FET that's on the agenda, it's activity 3, electromagnetism in a nutshell. She told me that this application doesn't work on Chromebooks, and I don't know if it's just hers or whatever, but I just want to walk through that real quick, just in case it doesn't work for you. And I will post this video right on that activity so you can see as well. So the electromagnetism in a nutshell assignment has you go through each of these tabs and sort of make some observations. So I'll just walk you through those. The first one says, go to the bar magnet tab and look at it. So you see this is the bar magnet right here. And the first question sort of has you sort of analyze how many sides or poles that this magnet has. And you can see that there are two. There is a North Pole and a South Pole, and if that sounds familiar to you because you think that Santa Claus lives at the North Pole and there's penguins at the South Pole, it's because Earth is actually a magnet as well. It's magnetic, and that means that there's a North Pole and a South Pole, and it's very strong, and other magnetic things are attracted to that, and that's how compasses work. So this is what's called a bar magnet, and just like the Earth, it has a North Pole and a South Pole, and that is going to determine a few things that we'll get into later. So this right here is a magnet, or excuse me, a compass, and a compass, all it is another magnet that that interacts with what we call the magnetic field, right? So that's question 2. Under bar magnet, what are all these little arrows called? See these arrows, they're oriented and they kind of look like the compass, the arrows in the compass. Well, you'll notice there's some interaction here, right? So if I move the South Pole of the bar magnet next to the compass, it's attracted to the North Pole of the magnet in the compass, and vice versa is true, right? So the North is attracted to the South, red to white, white to red, and that is governed by this what we call the magnetic field. Is this field, right, that influences how these two objects interact. And magnetic fields are very, very complicated. For this application, all you have to understand is that a magnet will have this field, right? It will have this sort of sphere of influence around it. And that's very important for understanding what we're actually trying to get to, which is electromagnetism. Again, the fact that electricity and magnetism are related in some way. So the next one, number 3, says, click the pickup coil right here. And for those of you who already watched my electromagnet video, you'll notice that I wrapped a coil around a nail, and I was able to do some cool stuff with that. Well, look, I have a coil here, and I don't have a battery or anything like that. I just have a magnet. So this is the bar magnet, the same bar magnet from this tab, North and South Pole. You can see the field. The magnetic field is just sitting there. It's not moving, right? But if I move the magnet, the field starts moving, right? Now, look at the coil here, right? What do you think these blue dots are? Well, if you paid attention during our conductors and insulators portion, you know that this copper wire is a conductor, and that means it has loose valence electrons that is going to allow current to flow through it under certain circumstances. So these blue things are actually the electrons that are in the copper wire. And you see that it's connected, you know, there's a sort of a series circuit going on to a light bulb. So you see a light bulb here. So no big deal, right? We have a magnet, and then we have a coil of conducting wire attached, you know, in series to just a little light bulb. Well, watch what happens. When I move the magnetic field in relation to the copper wire, watch what happens. You should see that a couple things are occurring. One is obviously the light bulb is lighting up, but how is that happening? Where's the battery at? Well, we don't actually need a battery to induce a potential difference in the coil. All we have to do is really move the magnetic field, because the magnetic field, right, moving it is going to induce electricity in this copper wire, right? If I move a magnet, I create electricity. And I can do it the other way around too. I can move this around this. All it takes is just moving, the component of moving this magnetic field or moving this around the magnetic field is going to make current flow. And this is how we eventually get to how we make all our power, right? So let's get to that in a second. So the next one has us on, of course, the pickup coil, and it asks you to make some observations about what happens there. So go ahead and type in what you see on that, whether it's right here or on if you get the simulation to work, go ahead and write those answers, and then sort of complete that sentence, right? If I move electricity, what do I create? If I move a magnetic field, what do I create? So it should become very clear that moving a magnetic field creates electricity. What about moving electricity? Let's see what happens there. So complete that sentence on number 5, that series of sentences. If you need more help with that, of course, go to my electromagnetism video and check that out again. So click the electromagnet tab. That's right here. And you'll see that I have a battery, right? So very, very similar to the electromagnet that I created on my table and almost burned my house down. It's just a battery. Right now I have it at 0 volts. I can up it to 1 volt. And you can see the more voltage, not only the faster does it push the current, but the stronger the field is, right? So look how this is working. It's that same thing I showed you where we have this circuit, right? This simple series circuit and this coil right here moving the electricity, the current creates a field. So if there's no moving electricity, see how the electrons are not moving, there is no magnetic field, right? There's no magnetic field. I've got my compass here to check. No magnetic field. However, if I start moving electricity, it induces this magnetic field, and that's super important, right? This magnetic field right here is going to let us do so many things, right? So if I don't have a magnet, don't worry. All I have to do is make a circuit, and in the proper configuration with these coils, it's going to induce a magnetic field. Now, what is this made of? It's just simply a battery and a circuit, except in this simple series circuit, I've wound the coils around a few times, and we call that a solenoid. We'll get into that in more detail a little bit later. But look at these coils. You saw me wrap the nail with these coils. These are coils as well, and that is instrumental to creating the electromagnet. And notice the more or less loops I make, it's going to affect the strength of the field as well. So not only just the voltage, but how many coils there are as well. So what are some of the uses of these? Well, our hard drives are electromagnets. That's how they sort of read and write information. You saw these big things that pick up junk in my electromagnet video, like the junkyard things. They can pick up a car and then move it and then drop the car. How? By first inducing current and then creating very strong magnetic field, and then you could just switch it off by shutting off the electricity. That's hugely useful, right? But even more than that, even more is this last tab, and this is sort of the very last thing. It's called a generator. Now, all this was leading up to sort of this point. I have here everything that I had in the last tabs. One, I have my simple series circuit with a solenoid, a couple of loops here. You can see there's no moving magnetic field, right? I can actually show you the field right now. You can see that it's not moving. Here's the compass. And then here's the bar magnet, right? So they're next to each other, and you should already know that this isn't illuminated. The electrons are not moving in the circuit because the magnetic field is not changing. It's not moving at all, right? Now, what happens if I move it? You know what's going to happen. This is going to light up. But what if I create very clever ways to move the magnet? For example, if I put it on a wheel and a spindle and I run water over it, look at that. I'm spinning the magnet, which is moving the magnetic field, and the moving magnetic field induces a current in the conducting wire, in the circuit. What I'm literally doing here is taking the properties of electromagnetism, magnets working in conjunction with electricity, and I am changing the falling water, right? The energy, the gravitational potential energy of the falling water to change that into electrical energy. This right here is how the world works. This is a very simplified version of it, but everything, life as you know it, revolves around our ability to make electricity by turning some other type of energy, maybe the energy from the sun or from wind or from hydropower, this is like a dam, to move a magnet. And because we figured out that if you move a magnet, you can create moving electricity, and moving electricity is called current, and current is very useful because look at this. It's powering this light bulb. This is how the world works. This is how a generator works. This is called an electric generator because we're generating electricity, right? We're taking one type of energy, right? Gravitational potential energy, this falling water. Where can you find those? Waterfalls, dams, stuff like that. We can make that. Swapping one type of energy for another through the understanding of the relationship of magnets and electricity. This is electromagnetism. And there's more to it. We're going to get to that on Thursday. But that should help you walk through that exercise. Activity 3, electromagnetism in a nutshell. This video is going right up there by the activity. If you cannot access this, at least you have this to look at to answer those questions. Again, if you have any questions, hop in my Zoom meeting the next time that you're supposed to be there, or just go ahead and send me an email with your questions and we can work it out. All right, guys, let me know if you need anything.